This video is a review of a chapter on quadratic equations. So our first concept is solving a quadratic equation by taking square roots. The most important thing for us to remember right here on these problems is that quadratic equations, which have an exponent of 2 with their variable, this squared here, in general, like most of the time, are going to give us 2 answers. So the fact that we should be getting 2 solutions or 2 answers on each of these problems is hopefully going to help us avoid a common mistake. When I solve x squared equals 36, my mind is supposed to think, what squared gives me 36? And the obvious answer, the relatively obvious answer, is 6, but there's also a less obvious answer of -6. Because when you do -6 squared, which means to do -6 times -6, the negatives cancel each other out and give us positive 36. The other way to think about doing this problem is what the instructions say, by taking square roots. If I square root each side of my equation, it cancels the squared out here and leaves me with x. When I square root the 36, I have to remember that when I, as a mathematician, square root in an equation, that I have to think about the positive and negative answer of positive 6 and -6. So whichever of those 2 ways you want to think about is fine. They both have their merits. As long as it's something we can square root, the first way is pretty easy to think about. We'll come to a problem later on, though, where the second method of actually writing the square root symbol might help us out. So let's look at number 2. Now this time we have to do some solving before we think about what n squared could equal, because right now n squared plus 6 equals 70. The easiest thing to do is to go ahead and subtract that 6 over, just like if it was a linear equation. The good old days of linear equations. If we subtract the 6 over, now we see that n squared is supposed to equal 64. Again, either think in your head what squared equals 64, remembering that there's 2 answers, or square root both sides to cancel out the squared so that we get n equals, and think about the square root of 64, which is 8, and since it's an equation, we would also put -8. There's also a way that we can write these together, that you can use a plus and minus sign to say that it's plus and minus 6, or on the second one, plus and minus 8. And when people look at that, they know that you mean that it can be either of those 2 answers. Number 3, similar situation. We've got this -3 that we want to move, so I'm going to add it over to the other side. P squared equals 33. And then I'm going to square root both sides of my equation to get rid of the squared that's on P. And this is where it's actually helpful to do this. So we know that we're supposed to get 2 answers because it's a quadratic equation. We want to figure out what the square root of 33 is, but we can't. We're not using our calculator. We're just simplifying as much as possible. So the only thing I can do with square root of 33 is write the square root of 33. We can't even simplify it because if we make a factor tree, which this is something we'll do in a little bit, 33 is 3 times 11. There aren't any perfect squares there, so that I can't simplify the square root at all. The only thing I could do is if my teacher asked me to, I could put this into the calculator and find a decimal, but I'm not being asked to do that on this question. Number 4, I've got 2 steps here because I need to subtract the 3. We just have to pretend basically for the first part of the equation that the squared isn't there and think about what would I do if this was just 2x plus 3 equals -3. I'm going to subtract the 3 over to the other side to move it. I'm going to divide both sides by 2 and get x squared equals -3. And then I'm going to think about the square root of both sides. Now, this is another concept issue. We, at this point in Algebra 1, don't know how to square root a negative number. And in fact, we would say that there's no real answer to that. So that means that this equation has no solution, and technically it's that it has no real solution, because when you get to Algebra 2, or maybe later on in your Algebra 1 course, who knows, you'll talk about the solutions that you can get here are imaginary. But for our purposes right here in Algebra 1, we would say that this is no solution because we can't square root a negative. So notice it wasn't the fact that there wasn't a square root of 33 that made us had no solution. We still had a solution to that problem. It's the fact that I tried to square root a negative number that gave me no solution. And that has to do with the fact that when you multiply a negative and a positive together, you get a negative. But this is not a situation where we could say something squared, right? If I make them both negative, then it's positive. If I make them both positive, it's still positive. There's no way to square something and get a negative number. So that's why square rooting a negative gives us no solution. Here on number 5, I want to solve similarly to how I did on number 4. I want to add the 2 over. As people were working through this problem, a lot of people asked me what they were supposed to do at this point, or like, oh, there's no solution. And many people just didn't even try to divide 6 into 90, which I thought was interesting. Even if you didn't think 6 went into 90, we could always divide both of these by 2 because they're both even numbers, and then try to simplify further. 45 divided by 3 is 15, and that means 90 divided by 6 was 15. When I square root both sides of my equation, I get x equals plus and minus. And since I can't do anything with the square root of 15 because it's 3 times 5, so there's no perfect squares, and it's not something that is a perfect square itself, then I just leave it as positive and negative square root of 15. Each of these problems you could write the answer as 2 separate things like I did on the first 2, or you can write them together like I did on 3 and 5. It doesn't matter which way you write it as long as you have a positive and a negative for your answers. Now let's talk about simplifying square roots. So this is kind of similar to what we do with fractions, how we want fractions to be as reduced as possible. For square roots, we want the number inside to be as small as possible. So what we typically do is we make a factor tree for whatever number is underneath, and what happens is if there's a pair of numbers, we just look at the numbers at the bottom here, 2, 2, and 5. If there is a pair of numbers, then together that makes something we can square root. Together this is 4, and I know that the square root of 4 is 2. So this pair of numbers lets me put a 2 on the outside of my square root, and whatever number is or numbers are left over, we're going to put back on the inside. In either case, like if there's more than one pair of numbers, I put them all on the outside and multiply them together. If there's more than one number left over that doesn't have a pair, like if there was a 5 and a 3 and a 7, those would all go back underneath and multiply together. So the square root of 20 is the same as 2 square roots of 5. The other way to do it is just to simply try to think about the perfect squares that are inside of 20, and then to say, well, since square root of 20 is 4 times 5, I can square root 4 and get 2, but I'd have to leave the square root of 5. So I get 2 square roots of 5. Whichever way is easier for you to think of, that's how you should try to do it. On number 7 here, we've got 3 square roots of 72. Let's ignore the 3 for now and just worry about the 72. And we'll come back and get the 72 later. So I'm going to make a factor tree. 72 is kind of a big number, and so it might be harder for us to think of the perfect square that works. Also, it might be that we think of 9, which is a perfect square, and go ahead and work with that. But we have to make sure that we keep removing perfect squares. So what I mean by that is if you did 9 and 8 and said that was 3 square roots of 8 and then went about your business, you'd be not completely right, because the square root of 8 also has something that we can simplify inside of it because it has 4 times 2. So that's one of the reasons I like factor trees, is because it helps us make sure that we it helps us make sure we simplify it as much as possible. I have a pair of 2s, a pair of 3s, and a 2 that does not have anybody to pair up with. So the pair of 2s makes there be a 2 on the outside, because a pair of 2s is like the square root of 4. This pair of 3's is putting a 3 on the outside because the square root of 9 is 3. This 2 is left over on the inside. Nothing else is left over on the inside. And now we're going to bring our 3 in front, and we're going to put a multiplication symbol between, because even though they didn't write it here, there is a multiplication symbol between the 3 and the square root. So that means I can do 3 times 2 times 3 and get 18. And then the square root of 2 just stays the square root of 2. So this is my answer. On these next problems, there typically is more than one way to do it. For instance, I can think about 10 times 6, which is 60, and make a factor tree, or I can just factor tree these right now and look for a pair. I don't even actually have to multiply them together to see that there is a pair of 2's, which is going to put a 2 on the outside, and there is a 5 and a 3 left over to put on the inside, and this 4 should also be on the outside. Make sure you remember that whatever is on the outside like this is going to multiply together, not add, not just be next to, looking like a 42. And that if we have more than one thing on the inside, those need to get multiplied back together. So this ends up being 8 square roots of 15. If you started it off by multiplying them together, 4 square roots of 60, you should come to the same conclusion by simplifying square root of 60. Number 9, again, you can multiply them together, and I think that this proves that it is helpful to at least think about multiplying them together, because if I multiply them together and get 100, we know what the square root of 100 is. It's just 10. And there's actually this cool property where if I multiply two things together that are the same, if I multiply two square roots together that are the same number, it basically cancels the square root out and leaves me with what's underneath. But we also could have said, oh, there's a 2 and a 5 and a 2 and a 5, and so I have a pair of 2's and a pair of 5's, and I don't have anything left to go inside. When you don't have anything left to go inside, you don't put a square root. That means that it's a perfect square. And we do 2 times 5 and get 10 anyway. On number 10, so either we need to think about this property that if they're both under the square root, we can go ahead and simplify. Or another way of thinking of it is to break up the top into square root of 3 and square root of 2, because 3 times 2 is 6. I kind of like this way better visually, like we can see that that means the square roots of 3 would cancel out, and that leaves us with just 2 square roots of 2. If we do it the other way, where we do 6 divided by 3, we get 2, and we have to know that we didn't do anything to get rid of the square root, so it's still under the square root symbol. Our answer is 2 square roots of 2. There are at least 2 different ways to do 11. Either to split these up into their parts. It's not a bad idea to do that, and it's up to you as far as do we want to just completely split them up into primes, or do we want to split them up differently, because square root of 16 has a lot of 2's. One way to do it is just to do this, to split it up basically by making a factor tree and say 16 is 4 2's multiplied together, 20 is 5 times 2 times 2, and that shows us that these cancel. And so then I'd put things back together. I'd say, okay, square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is really just 2. And since this is really 2, I'm going to do 4 times 2 and get 8. The other way I think that's most common to do this is to say, what is the square root of 16? It's 4. So on bottom we're going to have 4 times 4, which is 16. And then to simplify 20, because 20 is 4 times 5, so we can square root the 4 and have the 5 left over, and then we'd cancel the 2 and the 16, and that's how we end up with just 8 on bottom and nothing in front of the square root of 5 on top. So that's at least 2 different ways to do that one, and there might be more than that. This is one of those things where most of the time, if you got the right answer and you did it a different way, you probably did something correct. It doesn't hurt to check with your teacher, because there are ways to accidentally get the correct answer, but in general, probably did it right if you got the right answer. Switching to a new thing, we are going to look at graphing quadratic functions. So it says up here at the top, what is the formula to find the vertex? So the vertex, by the way, is the highest or lowest point of our parabola, and the formula for it is negative b over 2a. This is actually inside the quadratic formula. So here in a second, we'll have the quadratic formula that we need. And this is what the quadratic formula looks like. And I'm writing this to point out to you that in some ways we're not having to memorize a new formula because this is right here in the quadratic formula. So if we pretend this isn't here, we have the vertex formula. Now, to be able to graph this, we need to know what a, b, and c are to plug in a and b into this. So our standard form for a quadratic function is to have y equals ax squared plus bx plus c. So the number in front of x squared is a. So in this case, a is -1. Remember, when there's not a number in front of a letter that it has to be a 1, and in this case it's negative. But there isn't an x or a number out to the side, so b has to be 0 and c has to be 0. So when I plug this into negative b over 2a, b is 0, a is -1. Doesn't really matter what the bottom is because 0 divided by anything is 0. So right now I know that the x value for my vertex is 0. I'm going to put that in the middle of my table of values and pick two numbers either direction. So -2, -1, and 1 and 2. It doesn't matter which order you put them in. We just want the 5 numbers closest to our vertex, or I guess the 4 numbers closest to our vertex, because the 5th number is our vertex. We're going to plug all 4 of these into our original function. And there's a thing here, a mistake that is very common when we make here. If I start with -2 and I plug it in and I say -2 squared, a lot of people want to cancel this negative out and say this is +4, but that is incorrect. What we're doing here is we are squaring -2 to get +4 and then thinking about the negative in front. I think an easier way to visualize this is to remember that squaring means to write twice. So it's not that I have 2 negatives that cancel, I really have 3 negatives, and 3 negatives overall makes a negative. So -2 goes with -4. When I plug in -1, same thing happens where I square and get a positive, but then it turns back negative. So it's a -1. 0 squared is just 0, and making it negative, it's still 0. Then if you've done enough of these problems, you'll know that there is a pattern here, that when I plug in 1, I should get -1 again. When I plug in 2, I should get -4. Now, this can be helpful to go ahead and plug these in to double check that you're right on the first ones, because if you plug in -1 and 1 and you don't get the same answer, you know that one of them is wrong. But also it means that we could have just plugged in 1 and 2 instead of -1 and -2, which may have been easier since they weren't negative. So keep that in mind, that you can choose whichever side of your vertex to plug in that would be easier to work out. I'm going to finish filling in my vertex up here. So the vertex in this case is the highest point, and then we've got -1, -1, -2, -4, 1, -1, and 2, -4. And then we connect this best we can as a smooth curve. I will admit that my computer drawing skills sometimes leave a lot to be desired. Now notice that this graph opened down. The opening is down here. And I point that out because we could tell that before we started. When the number in front of x squared is negative, that means our parabola should open down. When it's positive, like it is here, we have nothing in front of x squared, so it's a positive x squared, this graph should open up. And so you could be asked to tell that without actually being asked to graph. You'd be asked, which way does this open? And you could know just by looking at what a is. So on this one, a is the number in front of x squared, which is 1. B is what's in front of x, which is -4. C is our number left over, which is 5. And we're going to plug this into negative b over 2a. So a negative, negative 4, because b is negative, but our formula has a negative, over 2 times 1 gives us positive 4 over 2, which is 2. So we need to pick two numbers on either side, so 0, 1, 2, 3, 4. And so this is where I was saying, let's be smart, and if we're only going to plug in 3 numbers, let's pick the easier numbers, 0 and 1, as opposed to 3 and 4, which give us bigger things to work with, which just makes it more likely that we'll mess up, in theory. I mean, supposedly 0 is the easiest thing to plug in, but only if you do it right, because 0 squared is 0, negative 4 times 0 is 0, so we just get 5. And plugging in 0 should always work nicely like that. So top and bottom should be 5. 1 squared minus 4 times 1 plus 5. 1 squared is 1. 4 times 1 is 4, but it'll be a minus plus 5. I personally like to do this part. 1 plus 5 is 6, and then minus 4, which is 2. And then 2 squared minus 4 times 2 plus 5 is 4, minus 8 plus 5, which is 9, minus 8, which is 1. So we have the vertex 2, 1. Since it opens up, this should be our lowest point. And then we've got 1, 2, and 3, 2, and then 0, 5, and 4, 5. If you're looking at my scale on this, it goes by halves. So you got to be careful that you put your points in the right place. Again, I would draw better if I was on paper than on the computer. So, and see, it does in fact open up like we predicted. I have a couple more of these problems. So this is the point where if you have not already tried to do problems like this on your own, you should pause the video and give it a try, and then start the video back up either when you get stuck or when you're finished to see how you did, or even skip ahead to where I have the answer if you're super confident that you did it right. So if you're continuing on with me, A is negative 2, B is 16, C is negative 35. Now these are some bigger numbers, which is a little frustrating to have to work through. It's more likely that we'll make mistakes, but I believe in us. We can do this. So that's negative 16 over negative 4, which simplifies to be positive 4. And so our numbers on either side are 2, 3, 5, and 6. So I think we'd be better off plugging in the smaller numbers. At least they're positive. That's super helpful. All right. So when we do this, we always square before we multiply. Remember that good old PEMDAS where exponents came before multiplication. I do 2 squared and get 4, and then multiply by negative 2 and get negative 8. In this case, you could have done it the wrong way and still gotten the right answer, but in general, that's not the case. 2's are special like that. 16 times 2 is 32. We've got minus 35. So you can do this as long as you take the negatives correctly in any order. Like I would do 32 minus 35 and get negative 3. And then negative 3 plus negative 8 gives me negative 11, which at first might seem like a bad number to get, but if we look at our graph, there is a negative 11 on there, so it's a good sign. Now let's plug in 3. So 9 times negative 2 is negative 18. This is where if we did it the other way and got 6 and then squared it, we would be wrong. So let's not do that. 16 times 3 is 48. Negative 18 plus 48 is 30, and 30 minus 35 is negative 5. And then we just need to plug in 4. So see, these numbers, they're getting so big. 4 squared is 16, times negative 2 is negative 32. 16 times 4 is 64. So negative 32 minus 35 is negative 67, plus 64 is negative 3. So our vertex is 4, negative 3. We could have predicted, but I forgot to, this opens down. So at 3, we're at -5, and at 5, we're at -5. At 2, we're at -11, and at 6, we're at -11. And there's our parabola. So again, if you haven't already, you might try pausing the video, do this problem on your own, see what happens. Although, before you do pause it, remember that this would be like a +0 at the end, so C is 0. Not that it really matters, because we don't have to actually plug in C for any particular reason here. So A is 1, B is 2, C is 0. So our formula is -2 over 2 times 1, -2 over 2, so -1. And we need to pick 0, 1, -2, and -3. I have consistently been doing this in the opposite order. It doesn't matter which order you put your numbers in on your table of values. So if you put 1 and 0 first, that's fine. If you put -3 and -2 first, that's fine. We just want to pick the closest numbers to -1 that we can. So I'm going to plug in 1. 1 squared is 1 plus 2 times 1, which is 2. So at 1, I should be at 3. 0 should give me 0 plus 0, which is 0. 0, 0, 0. And -1 is 1 minus 2, which is -1. So my vertex is -1, -1. It should be opening up. I have 0, 0, -2, 0, and then 1, +3, and -3, +3. There's actually a pattern here, even more so than just the symmetry happening, that you could look back at these, most of these at least, and maybe see what the pattern is for how far apart these points are. You definitely talk about it more in Algebra 2 and about how to graph this without having to plug in all these numbers. But honestly, right now where you're at in math, it's probably easiest just to go ahead and plug them in than to try to memorize or understand the pattern that's happening. But you're welcome to give it a try if you want to. Quadratic formula time. So first off, and I put the quadratic formula a couple of slides ago, the quadratic formula is x equals -b plus or minus square root b squared minus 4ac all over 2a. Just like in the last one, we decide what a, b, and c is. In order for us to figure it out, everything needs to be on the same side, and we want it to be the squared term, the regular term, and then the number, so that it goes in alphabetical order. So a is 2, b is 8, and c is 3. And we'll plug it in to our formula. So x equals -b, so b is 8, so that's -8 plus or minus the square root of b squared minus 4ac all over 2 times a, which is also 2. So the first things we normally do is if we had anything to do with the -8, we would. Like if it had been a negative, like if there were 2 negatives here, we'd make it positive. There's not, so we won't do that. It's just going to stay. The next thing is multiplying on bottom and getting 4. And then we want to go ahead and do 8 squared, which is 64. We want to do 4 times 2 times 3, which is 24. And so we're going to minus 24 because of this minus. If either of these were negative, if one of them was negative, it would change it to positive. If both of them were negative, it would still be minus in the middle. And then we're going to do 64 minus 24, which is 40. And then we're going to say, what is 40 if I simplify it? Like what we did on an earlier set of problems. Well, we have a pair of 2's and a 2 and a 5 left over. So the square root of 40 is 2 square roots of 2 times 5, which is 10. Now, the only way we're allowed to simplify the negative 8 and the 4 is if we can also simplify square root of 40 and have a number out here. When I look at this, I look at all 3 of these numbers and say, is there something I can divide all of them by? If not, I don't do anything. If there is, then I go ahead and divide all 3 of them. So I'm going to divide them all by 2, which gives me this. I don't need the 1 right there. I can leave it or I can take it off, but my answer here is negative 4 plus and minus the square root of 10 over 2. I can't simplify the negative 4 and the 2 because there's not also a number in front of the square root that's also divisible by 2. Has to be in all 3 places. On 17, you can actually start this off by dividing everything by 2 because they all have that in common. And if I divide everything by 2, including the 0, I haven't done anything illegal as far as equations go. If we didn't notice that, we'd just say A is 2, B is negative 8, C is negative 24. You can see how the helpfulness in dividing by 2 is having smaller numbers to work with. So this really should have been an N right here. X equals negative 8, which will change to a positive here in a second. When B is already negative and you plug it in, it's going to switch signs just like on our vertex formula. And then I'm going to do negative 8 squared minus 4 times 2 times negative 24 all over 2 times A, which is 2. So the negative 8 turns to positive. 2 times 2 on bottom is 4. Negative 8 squared is still 64. But here I have a negative times a negative, which is going to make there be a plus. 4 times 2 times 24. 8 times 24. 192. And then I have to do 64 plus 192, which is 256. It's always helpful to check and see if this is a perfect square. So I actually have a list of squares on my board to help out with that, or if we did a factor tree, we should notice that all the numbers pair up. The square root of 256 is 16, and once I take the square root, the symbol goes away. Now we could simplify this like we did over here where we divide everything by 4, or we can just go ahead and split it up. Since I got rid of the square root, I actually want to find these 2 answers, one where we've got a plus and one where we've got a minus. 8 plus 16 is 24, over 4 is 6, and 8 minus 16 is negative 8, over 4 is negative 2. So my 2 answers are 6 and negative 2. So if you can get rid of the square root, you should go all the way to your 2 answers. If you can't find the square root, you just leave it as, you can leave it as plus and minus whatever the square root is. On these 2 problems, we have to start by getting them to be equal to 0 and in the right order. So on 18, we just need to subtract the 2. If we don't, we'll have the, and we say that C is 5, we're not going to get the right answer. A requirement for using the quadratic formula is everything needs to be on the same side. I didn't do it on the last one. I pointed out we could have divided everything by something, but here, look, they're all divisible by 3. Let's divide this whole thing by 3 and get v squared minus v plus 1 equals 0, because 0 divided by anything is still 0. Which means A is 1, B is negative 1, and C is 1. And unless we're just really bad at dealing with 1s, it should be easier because we have smaller numbers, although 3 is not a very big number. So we have negative B, so negative 1, B squared minus 4AC all over 2A. So we get a positive 1 and a 2 on bottom. And then we've got 1 minus 4. But 1 minus 4 is negative 3. If you remember what we talked about earlier, we are not allowed to take the square root of a negative number. And so because of that negative under our square root, this is no solution. And then we don't have to try to keep going at all. So it's the fact that it's a negative under our square root, not the fact that it's a 3. It's that it's a negative. 19, we need to rearrange this, so we could either move both of these over to the left or just subtract the k over to the right. When we do subtract it over, we're not actually subtracting it from anything, and we're going to strategically place it in the middle because this is the order we want to have, is k squared, k, and then our number. So a is going to give us negative 3, b is going to give us negative 1, and c is 6. If you haven't already tried doing one of these on your own, I recommend that you try on this one. We are going to just plug it in and solve it. So our negative b turns to positive 1. And then we've got 1. We got 2 negatives, so that's going to make us add. 4 times 3 is 12, times 6 is 72. 2 times negative 3 is negative 6. So 1 plus and minus square root is 73 over negative 6. Square root of 73 is a prime. 73 is a prime number, and so there's nothing we can do. If we did this differently, we could have instead ended up with negative 1 on top and a positive 6 on bottom. These are the same answer, so whichever of these you came up with, you would be correct. If you did not have a negative either on top or bottom, then you'd lose a point on that because that suggests that you didn't get everything, didn't get everything on the same side, which is not how we do the quadratic formula. But I think that also would have changed another number somewhere probably. But one of those two things, not both of them, is your answer. Finally, when we talk about the quadratic formula, we also typically talk about the discriminant. The discriminant is a special part of the quadratic formula. It's the part that's underneath the square root. So we used the rest of the quadratic formula for the vertex. This is the part under the square root. When you find this number, b squared minus 4ac, a positive answer means 2 solutions. A 0 answer means 1 solution. And a negative answer means no solution. And we could put the word real in between all of these, and that would actually be more correct. So we're going to do the same thing we've been doing, where we pick out A, B, and C, and there is no C on this one, so C is 0. And we're going to plug into b squared minus 4ac. And notice it doesn't even have the square root. It's just what's underneath. So this is 81. This becomes 0. So either 81 plus 0 or 81 minus 0. Our discriminant is 81. Since that is a positive number, we have 2 solutions. On 21, A is 1, B is a negative 4, and C is positive 4. We're going to plug into b squared minus 4ac. So that's 16 minus 16, which is 0. A 0 for an answer gives us 1 solution. And for this last one, they're trying to trick us. By they, I mean me. I'm trying to trick you because I made this problem. We have to move everything to one side, just like with the quadratic formula, just like with, I guess that's actually the only thing I'm thinking of. Just like with the quadratic formula, we have to make sure everything's on one side before we label A, B, and C, or we're going to end up with a wrong sign somewhere, or maybe a wrong number, depending on what the situation is. So they're all positive. 2 squared minus 4 times 7 times 8. So 4 minus 28 times 8 is 4, 6, 16, 224. Minus 224, so that's negative 220. That's a negative number. if you look at the instructions, it says find the discriminant. The discriminant is negative 220. If you don't write negative 220, you didn't find the discriminant, just by the way. But a negative number means there are no solutions. So it's kind of like we have two parts to our answer on this section. One is the number that we get from b squared minus 4ac, and the other is telling how many solutions there are. So this has been a review of quadratic equations from Algebra 1. Happy studying.
If you like this video, please hit the thumbs up and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching!